Hey ChemStars, welcome to your Chapter 9 Stoichiometry practice for Level 2 Chem. Just a note for Chapter 9 homework, Level 2 and Level 1 have really similar pages, so at the top of the video I'll try and make a note. So for page 1, the naming review, Level 2 Chem is not the same as Level 1. Level 1 has some added acids, but we'll make two different videos for that. So let's start at the beginning. Chapter 6 and 7 naming review. You got to know your polyatomics, your Roman numerals, your covalent prefixes, and naming rules. Some things I'd have out with you. I would have out your polyatomic ion list, also your colored periodic table that has the charges and where we need Roman numerals. So let's go through. I want to start with covalent, where we have two or more nonmetals. These are the easiest ones because of WYSIWYG. What you see is what you get. So let's go through first and let's try and find everything that has two or more nonmetals. Okay, difluorine monoxide. Fluorine, oxygen, those are both nonmetals. If you check the periodic table, they're to the right of the stair-step line. And we also know it's a covalent because we see these prefixes. So it's going to be covalent, and what you see is what you get. So di means two, and mono means one. So difluorine, two fluorines, monoxide, one oxygen. F2O is difluorine monoxide. Okay, nope. Aha. Nitrogen tetroxide. So we see the prefixes, and if we check, nitrogen and oxygen are both nonmetals. So let's find the covalent formula here. This is going to be covalent. Dinitrogen is N2. Tetroxide means 4, so it's N2O4. Okay, I'm skipping over the ionic ones. We want to get all the easy ones done first. Aha, look at 11, 12, and 13. These are our common covalent compounds that have common names. So water, ammonia, and methane. We memorized those in Chapter 6. You memorized that water is H2O, ammonia is NH3, and methane is CH4. Those are our preferred names for those. And let's scan down our list. Sulfur Trioxide. Check your periodic table. Sulfur and oxygen, yep, they're both right of that stair-step line, so they're nonmetals. So these are covalent, and we'll use our prefixes. So tri is 3. Sulfur, there's no prefix. That implies there's only one, so sulfur trioxide is SO3. Okay, everything else we have here is a metal. So these are going to be ionic compounds where there's a positive cation and a negative anion, which means there's going to be a metal and then followed by a non-metal. Or maybe a polyatomic and then another polyatomic. Let's start with some of the easy ones first. So sodium sulfide. Sodium is Na1+, sulfide is S2-. How do I know that? I check the periodic table. Sodium's in column 1, it's always a 1+. Sulfur is in column 16, it's always 2-. So sodium sulfide, I'm going to do my crisscross. This is an ionic compound. It's a simple binary. You don't have to write the simple binary part. I'm just reminding you of the vocab we've been using. So sodium sulfide. If I've got a 2-, I got to get a 2+. So do your crisscross. It's going to be Na2S. Okay, that one looks kind of complicated. Let's see. Let's try and find another easy one on the list. Well, okay, nothing else is easy, so we've got to go into some of our polyatomics. Let's go ahead with that then. So our polyatomics, ammonium, if you check your polyatomic list, ammonium is right here, NH4 1+. So ammonium is NH4 1+, and then nitrogen on the periodic table, nitride is always in the 3- column. So we have N3-. So do your crisscross. We got to get a 3+ to balance out that 3-. So it's going to be NH4. Now I need 3 of them. So use parentheses to show there's 3 of that group, and there's 1 nitrogen. Now these next ones I kind of like. These are fun because they tell you what the charge is on the metal. So iron, nickel, lead, gold, if you check your periodic table, they're all in this wishy-washy transition metal area where you need to have a Roman numeral. But go in this direction, they tell you what the charge is. So iron 2 is going to be Fe2+. And then we've got to check our polyatomic ion list for acetate. And acetate is going to be C2H3O2-. So C2H3O2 1-. Now we got to do our crisscross here. So the 1's charge is how many iron we need, but then iron's charge is how many acetate we need. So C2H3O2 2. Nickel 3 chlorate. Let's take a look at that one. Nickel 3, nice. They're telling us it's nickel 3+. Chlorate, you got to look up. and here it is right here, ClO3 1 minus. So nickel 3 chlorate, ClO3 1 minus. Do your crisscross. I'm going to need 1 nickel. I'm going to need 3 of the chlorates. So Ni, now I need 3 chlorates, so let's use some parentheses, ClO3, 3. Okay, let's look at our next section here, potassium nitrate. So potassium's a column 1 metal. Potassium's always going to be a 1 plus. You can check that on the periodic table. Oops, where'd it go? Check it on your periodic table. Potassium's right here, always going to be a 1 plus. And then, what was it with? Nitrate. We got to check nitrate. Nitrate is right here, NO3 1 minus. So K plus and NO3 1 minus. If we crisscross, it's just 1 and 1. Oops. Okay. We're in battery saving mode. So it's going to be KNO3. Now we've got some more easy ones coming up, kind of. Lead 4, they're telling you it's Pb4+. Bicarbonate, look it up. You're going to see it's HCO3 1-. So our formula, do your crisscross. Lead, you only need 1 of them, but then we're going to need 4 of the bicarbonate, also called hydrogen carbonate. Okay, gold 3 sulfate. Gold, Au, 3, 3+. Sulfate, look it up on your polyatomic ion list, SO4, 2-. Do your crisscross to see a 3+ and a 2-. That means we're going to 6 here. So gold 3 sulfate, we're doing our crisscross, and we're going to have Au2 parentheses, because we're going to have 3 of that whole sulfate group. Now I've got lead 2 iodide, so Pb2+. Iodide's a 1-. How did I know that? Well, go back to your periodic table. Here's iodine. It's in that column 17. It's always a 1-. So crisscross, iodide's charge is 1-. That means I need 1 lead. Lead's charge is 3. That means I need 3 iodine. I'm getting the positive and the negative charges to cancel. Okay. Let's look at a couple more. We're almost done. Copper 2. So it's going to be copper with a 2+ charge. It's a wishy-washy transition metal. Permanganate. Now be careful on that one. You got to check your polyatomic ion list, because permanganate is MnO4 1-, but then manganate is MnO4 2-. So this one wanted permanganate, giving it that 1- charge. So permanganate is MnO4 1-. So let's do our ionic crisscross. So copper, there's going to be 1 of those, and now we need 2 of the permanganates, MnO4 2. Calcium oxalate, so calcium's in column 2, always a 2+. Oxalate, that's the one that's always hard to remember. So look up oxalate on your polyatomics, C2O4 2-. So C2O4 2-. Now I got a 2+ and a 2-. They cancel out. They go to 0. If we did crisscross, you'd get 2 and 2. Remember, always reduce it down when you crisscross if you can. So it's going to be calcium C2O4, and that is calcium oxalate. We got one more left here. Zinc hydroxide. Now, when you're looking at zinc, remember it's one of those special ones. It's always going to be a 2+. So zinc, Zn2+, positive cation. Hydroxides, you look up on your list, and hydroxide is a 1-. If you don't trust me, here it is. Let's see, hydroxide right there. And so let's do a crisscross. So zinc, there's going to be 1, and then zinc's number 2 means there's going to be 2 hydroxide. Make sure you put it in parentheses. Now everything I left blank here, these were all of our ionic ones. You can go back and fill those in if it makes you feel happier. So these are all ionic. Anytime there's a metal, specifically anytime there's a cation, because we had one exception where it didn't start with a metal. That's where it started with, that's where it started with ammonium, but ammonium is a positive cation. So ionic compounds, remember, a cation and anion, covalent, 2 or more nonmetals. So then here's our quick review of our last chapter we had just done. So we're looking at here, single replacement. What do you check on the activity series? So remember I told you in class, you always trade up. You will never trade down. So if you think about who you're bonded with and who's trying to cut in, is it a trade up? If so, the reaction will happen. If it is a trade down, won't happen. Now for your double replacement reactions, you have to check the solubility table. We don't want aqueous, and aqueous. That equals no reaction, just stays in an ion soup. We do want maybe aqueous and solid, or aqueous and gas, or aqueous and liquid. Any of those things will imply that the reaction, I'm going to abbreviate here, the reaction works. Okay, so here's the end of page 1 video. I hope that you've gone through, corrected your work, and reviewed some of our naming rules. See you next time. Bye.